Before I jump onto the how to find out the formula on how to find out the confidence interval of one sample, what I'm going to talk about is I will briefly tell about what is the estimator. Okay, what do you mean by unbiased estimator? What do you mean by consistent? What are the characteristics of the estimator? Those kind of things. So an estimator is a sample statistic used to estimate a population parameter. For example, mean. Okay, if you want to know the mean of the whole population, what you do is you find out the mean of the sample, and then you try to use that number to the whole population. That is the estimator for the population mean. Sample mean is the estimator for the population mean. Similarly, if you want to find out the if you want to estimate the population proportion, then you can use the sample proportion, that is the estimate, okay, or the estimator for the population proportion, and so on. Okay, now an estimator is called unbiased if the mean of the sampling distribution of the estimator is equal to their population parameter. So what do you mean by unbiased estimator? Meaning that if you find out the mean of the sampling distribution, you know what is the sampling distribution means. If you find out the mean of the sampling distribution of that estimator, and if that value, that mean of the sampling distribution is equal to the population parameter, then that estimator is called unbiased estimator. For example, sample mean, if you find out the mean of those means, that is the mean of the means is basically the mean of the sampling distribution of the sample means, right? If you find out that, you will get the population mean. If you find out the mean of the proportions, sampling distribution of the proportion, then you will get population proportion. If you find out the mean of the sampling distribution of the variances, you will get the population variance. They are the unbiased estimator. Okay, sample mean, sample proportion, and sample variance are the unbiased estimator. But if you find out the mean of the distribution of the medians, distribution of the range, distribution of the standard deviation, they are unbiased estimator. They are biased estimator. I'm sorry. If the population is normal, the sample median is an unbiased estimator too. Okay. All right. The next characteristic of an estimator is an estimator is called consistent if the standard error gets smaller as sample size increases. Do you remember what were the standard error for the mean? When n gets to bigger, then the standard error will be 0, right? Because when n tends to infinity, when n is very big, then this quantity will be very small, 10 to 0. Similarly, n is in the denominator here too. If keep increasing n, then this will keep decreasing here too. Okay, that means if the standard error gets smaller as sample size increases, that estimator is called consistent estimator. Okay, for example, sample mean, proportion, sample variance, they are all consistent estimator. The next one is efficient estimator. An estimator is called efficient estimator if an estimator then others. Okay, an estimator is called efficient estimator than others if it has smallest variance. Okay, so if you want to estimate like a population parameter, and if there are more than one estimates available, okay, then the one with the smallest variance is called efficient estimator. It is also called the best estimator. Okay, guys. Now, how do we find out the confidence interval? First of all, let us talk about the point estimate. Point estimate is a specific numerical value obtained from sample estimate of a parameter. For example, sample mean is a point estimate for the population mean. Okay. An interval estimate is an interval or the range of values obtained by using the sample data to estimate the unknown parameter. For example, the average age of students is between 21.5 and 24 years. See, if you say the average age of students is 23 years, then that will be point estimate. But if you say the average age of the students in the population will be between 21.5 and 24 years, that will be interval estimate. So in point estimate, you give a number. In interval estimate, you assign a range of numbers. Okay, guys. So interval estimate may or may not contain the value of parameter being estimated. Sometimes the interval estimate may not contain the value of the real value of the parameter. A degree of confidence must be assigned before an interval estimate For example, we are 95% confident that the mean age is between 21.5 and 25 years. Frequently used confidence interval are 90%, 95%, and 99%. Okay. The confidence interval of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter. So if you are finding the confidence interval, that means the probability that the interval estimate will contain the true population parameter. Okay, assuming that a large number of samples are selected and the estimation process are on the same parameter is repeated. Okay, so this is what you saw in the statistics. So what I'm going to do is I will do one example by hand, okay, and I will show you how to do by using R. All right, guys. Okay, so what is the formula for the confidence interval for mean when sigma is given? Okay, so interval for mean when sigma is given or known. This is the x bar is the sample mean, g alpha half is the critical value, okay, for the alpha half left area, and the sigma is the population standard deviation and is the sample size. You have the same thing here, where g alpha is the g value corresponding to the alpha half. You can negative g alpha half is the g value for corresponding left area, and positive g alpha half is the critical value for the g value for the corresponding alpha half right area. Okay, so g alpha half is q norm, that is the critical value, that's why we use q norm. Q norm 1 minus alpha half 0 1, and sigma is the population standard deviation, and n is the sample size. Okay, let us see this. The birth weight of girls are normally distributed with population standard deviation 0.29. What is given? Sigma is given there, right? So sigma is 0.29 is given. If a sample of 15 girls, so what is given? N is 15, that is given. Have the following birth weights. The data is given, right? Data is given. So we will use this data to find out x bar. Okay, data is given here. So what is x bar? We will find out that x bar from the from R. Okay, or you can find out that using calculator. And then it says find 95% confidence interval. 95% confidence interval. So 1 minus alpha is 95%. 1 minus alpha is 0.95. So 0.95. What is alpha? Add alpha. And then subtract 0.95. You will get alpha equals to 1 minus 0.95. That will be 0.05. Since the formula needs alpha half, so alpha half will be 0.05 over 2. That will be 0.025. Okay, what is happening there is in the normal distribution, you are trying to find out the critical values for the left area 0.025 and then right area 0.025. Okay, so this is 0.025 and this is also 0.025. You are finding that critical value. We call this as negative g alpha half, this as positive g alpha half. Okay, so you are trying to find out that because we need that in the formula. There we need n is we have already, sigma is already there, and what we don't have is x bar and g alpha half. Okay, so to find out g alpha half, you do 1 minus alpha half, 1 minus 0.025, right? So what is g alpha half? Equals to q norm, right? And then you do 1 minus 0.025 will be 0.025 alpha half, and then 0, 1. You get q norm, right? 1 minus 0.025 will be 0.975 and then 0, 1. Let us use R for that, and then also what I want to do is also I want to find out the the average, the sample mean. Okay, because we will need sample mean too. How do I find out the sample mean? Is I want to do there. Basically there is data, right? So okay, I have copied that already, so I don't need to copy there. So let us find out what is the mean of data. Okay, if you find out the mean of the data, then you will get 3.174. That's what you get. Okay guys, so 3.174. Let us find out that. So that will be 3.174. Okay, So data is already, so we found x bar already. So what is the q norm of 0.975? Let us find out that too. So q norm, let me do it here, because this is here, right? So I will be using that confidence interval directly by using r. So q norm 0.975 and then 0, 1. That's what you get. So if you do that, you will get 0.8352. That's what you get. 0.8352. Oh, I'm sorry, I didn't use q norm, I used p norm. So it should be q norm, right? So because we are trying to find out the critical value or the g value, so q norm 0.975 and then 0, 1, 1.96. So this value is basically, this value is 1.96. So this is 1.96. Okay, now this will be, this value is in the formula. So what is the formula there? The formula is x bar 3.174 minus 1.96 times sigma is 0.29 over n is root under n is root under 15. So this is how you multiply that, and then also the same thing, right, with plus sign, 3.174 plus 1.96 times 0.29 over root under 15. That's what you do. Okay, guys. And then if you use calculator or if you use R, then you will get the answer there, right? So your answer will look like, let me see what your answer will look like. You will get 3.02. Okay, guys. So if you use calculator here, you will get 3.0227, right? And then 3.321, okay? 3.027 and 3. So you will get close to this number. If you get close to, you will be okay. All right. So you maybe differ because it depends on how many decimal places you take these values, okay? So so you will see similar numbers there. All right, now, so how do I do these things? This is a lot of work, right? So I don't want to do all these, but you need to know how to find out that. But there is a direct method to do that in R. How do I do that in R is, so first of all, you need the package. You need to install a package called Teaching Demos. All right, you need to install it. Just run it. It takes a little bit of time, few seconds, and after you run it, I ask you to comment it, meaning that you write that so that you don't have to run it again. Now after you run it, you need to call the library. So library and then do teaching demos. Let me run that, and then go to the data. Okay, I found the mean. I don't need the mean because I found the mean to do by hand, but what you need is you do g.test. So this is the same test that you use for the hypothesis testing, okay? But since I'm trying to find out only the confidence interval, what I'm doing here is I'm just running that z test that way, and then you get the confidence interval here, and you get the mean. The sample mean is mean of the sample data is 3.174, and you get the 95% confidence interval is that. Now if you want to know the 90% instead of 95%, you can do just change that and then you get those numbers, okay? But if you want to do by hand with 90%, you have to find out that you'll have to put that 90% there, and then you need to do that 90 and then 0.10, and you have to do a lot of things there, right? But the process is the same. So this is how you find out the confidence interval of mean when sigma is given, standard deviation sigma is given. Okay, guys. Now, what if the standard deviation sigma is not given? If sigma is not known, then the formula is similar, but it uses the degrees of freedom. Okay, it uses the degrees of freedom. You have seen this already. So the formula is x bar minus t alpha half, and then this is the degrees of freedom times s over root n. See, it is similar, but instead of g we have t, okay, and instead of sigma there is s. Because sigma will not be given, you will find out the sample standard deviation. S is the sample standard deviation, n minus 1 is the degrees of freedom, which is the sample size minus 1. Okay, so in that case what you do is, let me go to the R. In that case, instead of G test, you will be doing T test. So data is the same data set there. Okay, confidence level 90%, 95%, whatever percent you want to do. Okay, and then just run it. If you run, you will get, this is the 95% confidence interval when sigma. If sigma, suppose suppose that in this data set the sigma was not given. That is the assumption for this second example. Okay, suppose if the population standard deviation sigma or the population variance sigma was not given, then you will be doing just T test instead of the G test to find out the confidence interval. Okay, guys. Similarly, so let us do that. This was sigma not known. Now let us do that for the proportion. So the formula for the proportion is P hat is the sample proportion minus G alpha half times P hat times 1 minus P hat over n comma P hat plus that standard error. Okay, guys. So with G alpha half is the critical value for the alpha half right area. Okay. Let us look at this example. In a clinical trial of OxyContin, I think that OxyContin is the pain reliever. I'm not sure about that, but you can check. In a clinical trial of OxyContin, 16 subjects experienced headache among the 227. Okay, so what is X? X is 16, and then N, the total sample size is 227. So P hat will be what? X over N, that is the sample mean, a sample proportion. So 16 over 227, that is the P hat. Okay, guys. Construct a 95% confidence interval for the true proportion of treated subject. So if you want to do by hand, you will have to find out P hat, that is the P hat. Okay, and G alpha half, you do G alpha half as same as the confidence interval for mean, and P hat 1 minus P hat over N is the sample size. So you plug in those values here and then find out the numbers. But what I'm going to do here is I'm showing you how to find out these confidence interval directly by using the R. Okay, so the R code would be prop.test x equals to 16 comma n equals to 227. Okay, that's what we are doing that. And then confidence interval is 0.95 for 0.95 confidence interval. Okay, now so look at that. So what I'm doing here is exactly the same question. See, in a clinical trial of OxyContin, the exact same question. I'm doing prop.test. By the way, if you don't do the library, if you don't call the library, it will, all these will show the error. So you need to call the library every time when you close this file, and if you are going back and then opening this file, you need to, once you install it, you need to call the library and run that. Otherwise, it will not work. Okay. So let me run that. So what does it say? It says that the 95% confidence interval is, so 4.21 through 11.40, right? That is the percentage. 4.21% through 11.140%. Okay, or you can say the 95% confidence interval for the proportion is 0.0421 through 0.1140. Now, you may be wondering, what is the interpretation of this? What is the interpretation of that G test? Okay, what does that mean? That means one way of interpreting this is we are 90% confidence that the true population mean, the population mean falls between these two numbers. Okay, this is one way. The another way is, if you take the sample and find the mean, if you take another sample, find the mean, take another sample, find the mean, continue that way. 95% of the time, this is 90, right? So 90% of the time, that sample mean will fall between these two numbers. That's another way of interpreting. Okay, 90% of the time, the sample means will fall between these two numbers. That's what it means. Okay, similarly, what is the interpretation of this proportion thing is, one way is we are 95% confident that the population proportion lies between 0.042 through 0.114, Or if you calculate many samples and find the sample proportion, so 95% of the time those sample proportions fall between these two numbers. That's another way. Okay, this is the sample proportion. All right. Now the next thing I want to do is I want to find out the variance. Okay, so we do the q chi-square thing already. So to find out the confidence interval of variance, you need to install this pack, env stats. See, it is the uppercase, env stats. And once you install this, how do I install it? Just click here and then run. And once you install it, I think I have installed it already. So what I want to do is I want to just call the library. Okay, see, attaching the package this. Now what you do to find out the confidence interval for the variance, look at this. By the way, I have said something here. The sampling distribution of the variance is right skewed curve with mean sigma square, and standard error is that is the chi-square distribution. The chi-square variable is similar to the t variable in that its distribution is a family of curves based on the number of degrees of freedom. The symbol for chi-square is chi-square. So as the sampling distribution of the sample variance is chi-square distribution, the values of chi-square are all positive. Also, the total area under chi-square is 1. As the chi-square distribution is not symmetric, to find out the confidence interval, we need to find out the left and right chi-square value separately. So to find the chi-square value corresponding to 98% confidence interval when n equals to 12. So you can do that, right? So how do I do that one? Is you need to do the q chi-square, right? Q chi-square. See, q chi-square, since it is 98%. Okay, so the middle area is 98%. So this area and this area will be, so this middle area is 98%. So this will be 0.01% or 1%, 0.01, right? And then you do q chi-square 0.0111. You will find out that chi-square left, and for the chi-square right, because you need to enter the left area, total left area, right? 98% plus 1% is the total left area for chi-square r. You do that and you will find out the value of the chi-square. Now, how do I find out the confidence interval? Is, again, as I mentioned, you need to install the package env stats, and then you call the library for the first time. If you're doing first time, from the next time you don't have to install it, just call the library. We call the library already, and then do variance of the test x equals to data, okay, and confidence interval equals to 0.95. What is that data? So I'm using the exactly same data for the birth weight of the girls. Okay, since I have saved that as a data already, so it will catch that data. Okay, so what I'm doing is variant dot uppercase test, and then do that will give you the 95% confidence interval like this. Okay, so 0.063 through 0.295, that's the variance. So if you want to find out the confidence interval for the standard deviation, you take the square root of that. Okay, for the standard deviation, take the square root of that. All right, so this is the sample variance of that data. This is the confidence interval for the population variance, and this is 95% confidence interval. Okay guys, so this is how you find out the confidence interval for mean, when sigma given and not given, proportion, and the variance. So in the next video I will work on hypothesis test. Okay guys, thank you very much.